So let's jot those down really quickly. X squared plus y squared is equal to r squared. We will use that. We will use that x is equal to r cosine of theta. Y is equal to r sine of theta. And we may, somewhere down the line, use that tangent of theta is equal to y over x. Okay, that one's probably not used as much, but the first three we're definitely going to use. So if we are trying to go from polar form to rectangular form, we are looking for some of these equations to be in the equation that we're trying to convert. So number one, I don't see an r squared. So we're not going to use the first relationship yet. I do see an r and I see a cosine, but they're on opposite sides of the equation. If we attempt to get those on the same side of the equation, we would divide by cosine. So divided by 1 over cosine, that's secant. So that's not one of these relationships over here. So if we don't outright have one of those relationships, then we need to start thinking in terms of, is there something I can do to kind of manipulate this equation? So one strategy that we can use here is that if we multiply one side of the equation by something, as long as we multiply the other side of the equation by the same thing, we're within our mathematical boundaries there. So that thing that we are going to multiply by here is r. Okay, if we multiply both sides of the equation by r times r is r squared. And on the other side, we would just write that as 4r cosine of theta. Now what that has done is now we've got r squared. We have an equation involving r squared. R squared is equal to x squared plus y squared. So we are going to replace r squared with x squared y squared because that's what it's equal to. On the right side, r cosine of theta, that's equal to x. So now we have eliminated everything that's polar related. We've eliminated r and theta. Those are gone. We now just have x's and y's. Now, we don't really like the way that equation is written. We can't tell a whole lot from it. So let's go back to Math 3 for a minute and put this circle, because it is a circle, put this circle in its standard form. That's the word I was looking for. Okay, let's put this in its standard form. So to do that, we need all of our x's and y's on one side. So we're going to subtract the 4x to the other side. So for the moment, we have x squared minus 4x. If you remember, we're going to complete the square, so we need to leave ourselves a space right there before we write our plus y squared. And then on the right side of our equation, 4x minus 4x, that's 0. Okay, so if we complete the square, we take this linear term, divide it by 2, and square it. So negative 4 divided by 2 is negative 2. Negative 2 squared is positive 4. Now, if we add something to the left side of the equation, we got to keep it balanced and add the same thing to the right side of the equation. So now that is equal to 0 plus 4. The whole purpose of this was to put this in standard form. So we factor. If you remember, this always factors. It's x, and it's either plus or minus based on this sign right here. It's the number that was squared. Okay, we divided negative 4 by 2, we got negative 2. That's always the number that goes right there. We didn't have to complete the square with y squared because it didn't have a linear y. And then the right side of the equation is 4. So now we can identify that this is a circle that has a center at positive 2, 0, and it has a radius of 2. Okay, a lot of review for Math 3 and circles right there. Yes. Right here? I completed the square over here on the left side. So if I add this 4 over here, I got to keep my equation balanced, and I got to add the same number to the right side. Okay. Any other questions? Okay, now, the instructions didn't necessarily say identify what this function is, but the reason why I want to go through that is because when we pull out our graphing utility here in a minute, we are going to check, we're going to look at what the graph looks like in polar form, and then we are going to check our answer here in rectangular form, and we've got to be able to recognize, are those the same graphs? Do they have the same characteristics? And all that. So, and this is really good review. Okay, let's do another one. R is equal to 3 secant of theta. So looks fairly similar to the one that we just did, but the results are going to be a little different this time. So R is equal to 3 secant of theta. Okay, so again, we are looking for any of these relationships that I have written up in the top right corner. We're looking for an R squared. We don't have an R squared. We're looking for R cosine theta. We don't have that. We don't have R sine theta. We don't have a tangent. Okay, so let's see, can we make one of those happen? So none of our equations have anything to do with secant, and we have secant in our equation. So how about we try and move that to the other side? Because if we divide by secant, 1 over secant is equal to cosine. 1 over secant, I'm just going to write that over to the side so when you look back at your notes, you know what happened right there. 1 over secant is equal to the cosine of theta. That's what happened between the original problem and step 2 there. R cosine of theta is equal to x. R cosine theta is equal to x. Our polar terms are gone. We just have an x and a constant, so we're in rectangular form. That is a vertical line at x equals 3. Okay, so some equations, depending on what they are, like the equation of a circle is a whole lot more simplistic in polar form than it is in rectangular form. But then some equations, like we just saw right here, a vertical line is a whole lot simpler in rectangular form than it is in polar form. It's kind of, I think it's kind of interesting how those relationships kind of work out like that. Okay, let's look at another one. R is equal to 2. R is equal to 2. Okay, so again, we're looking for those relationships. I'm not seeing one right off the bat because I don't have R squared, I don't have R cosine theta, I don't have R sine theta. So again, we're in kind of the manipulating game here. The easiest thing that we can do is turn this into R squared. So squaring both sides. Now, a minute ago, we multiplied both sides by R to get that R squared. Here, we don't want to do that because if we multiply both sides by R, yeah, sure, we'll get R squared on the left side, but 2R on the right side, that still leaves us with a polar term. But we're allowed to square both sides. So we've got R squared is equal to 4. Now we can replace R squared with X squared plus Y squared. Now, we don't have to complete the square on this one because we don't have any linear terms. Okay, so this is just a circle with a center at the origin because we're not adding or subtracting anything from the x and the y. And this one also has a radius of 2. Okay, last one. We've got theta is equal to pi over 3. Theta is equal to pi over 3. So our relationship that has just theta is that theta is equal to the inverse tangent of y over x. Okay, the relationship that has just theta is the inverse tangent of y over x. So let's replace the theta with inverse tangent of y over x. Now, we definitely don't want to leave it like that, because inverse trig and y and x are on the same side. So let's move some things around. If I want to get the y over x out of the inverse tangent, I move that to the other side. If I move inverse tangent to the other side, it's just the regular tangent. Okay, just using that inverse relationship there. The tangent of pi over 3, let's think about that one for a second. It's the sine over the cosine at pi over 3. So sine is the bigger value. It's the square root of 3 over 2. So let me do this work over here on the side. Sine is square root 3 over 2. Cosine is 1/2. Fraction divided by a fraction. Flip and multiply. So that simplifies to the square root of 3. And then we like our equations to be y equals. So multiply both sides by the x. So we get y is equal to the square root of 3x. Now, we're not used to really having square roots in our equations like that, but that is the equation of a line. That's a line with slope square root of 3. Kind of weird, but y-intercept 0, 0, 0, goes through the origin and has a slope of the square root of 3. So our equations of lines can look different in polar form. This one was just theta equals, we did one a second ago. It started out r equals 3 secant of theta. So it really just depends. Now, I told you I'm going to show you, once again, the power of Desmos. Here's what I love about Desmos. Let's look at that first one that we did. We had the original equation r equals 4 cosine of theta. Okay, you just type in the word theta and it'll put the theta there. And look at that. It graphs the circle right there. Now, if you go over here to the little wrench, below grid, you'll see there are 2 little circles right there. The one that's highlighted is your rectangular form. If you click on the other one, it changes the graph to polar form. Okay, so that would be graphing that circle on the polar coordinate system. But I think it's pretty cool that you don't actually have to change the mode to graph a polar equation on your rectangular axis. So it's pretty easy to observe what we came up with when we converted the equation. We said that the center was at 2, 0, right there, and it has a radius of 2. So it's very, very powerful here to help you check your conversions, or let's think about it, if it's multiple choice, oh, it doesn't want to do secant. I have to do it as 4 over cosine of theta, okay? So graphing the second equation that we did, r equals 4 secant of theta. Now, in the NC test version, it doesn't let you use secant, so you do need to know that secant is 1 over cosine. So I just typed in the equation as 4 over cosine of theta, and look at what we get. We get a vertical line at 4. Why did I say 2? Oh, I changed that number. Okay, 3 secant. It should be 3. Looking at the book. Okay, vertical line at 3. Excuse me. Okay, let's see here. What was the other one? R equals 2. Let's see if that'll do that one. Yep, R equals 2. Graphs that circle, centered at the origin, radius of 2. And then the final one that we did, theta equals pi over 3. Let's see if it'll do that one. Theta equals pi over 3. Oh, it doesn't like that one. It won't let you graph the theta equals. Okay, so you do need to know what's going on that one. You can't, Desmos is limited there. But otherwise, it will graph those polar graphs on the rectangular coordinate plane so that you can see them. It'll also graph it on the polar plane, but pretty powerful that you don't technically have to switch modes like you do with your standard calculator. You would have to change modes to be able to graph that. And it really, radians and degrees, really technically it doesn't matter. It just changes the scale there on the polar axis. Okay, any questions about graphing it or converting?